Hello, good day, everyone. Welcome to our fourth JWF webinar. My name is Reiko Yoshi. I'm a manager at Japan Water Forum. Before we get started, I would like to explain the flow of the webinar. First, on behalf of JWF, our director, Mr. Asai, will make our introductory remarks on today's webinar. After that, today's guest speaker, Mr. NAKAI Kazunori, will present about continuous efforts for stable water supply in Yokohama. Then we'll move on to the Q&A session. During Q&A session, we'll answer the questions that participants posted in advance. We'll give in 15 minutes. So if you have any questions, please post it in the Q&A box. We welcome all questions. Now, I would like to welcome Mr. Asai, a director at Japan Water Forum. Thank you. You have the floor.
Thank you, Reiko-san. Good afternoon, good evening, good morning, everyone. Welcome. I'd like to thank all of you for attending the fourth webinar of the JWF Webinar series. This webinar series aims to share Japan's practical know-how and experiences on how to address water-related issues and its long history of failures as well as success. Today's fourth webinar is going to feature the topic of urban water supply management. Safely managed water service is an essential for human life and health. It is also needed to free the people, particularly women and children, from the heavy burden of fetching water that is very time-consuming, dangerous, unpaid work. Facing the COVID-19 pandemic, we realized again that stable water supply is a vital measure against the infectious diseases, including COVID-19, as well as securing water, sanitation, and hygiene services. However, it is challenging how to operate, manage, and sustain water services to continuously ensure access to good quality water in sufficient quantity for all at an affordable price. At today's webinar, we have a distinguished guest speaker from the Yokohama Waterworks Bureau. As a water utility in Yokohama City, Japan, they will share their experiences and accumulated know-how of urban water supply management. I hope today's exchange and discussion will be informative and become a great starting point leading our future collaboration. Thank you.
Thank you for your remarks. Thank you for your remarks. Now let's move on to the introduction of the speaker. Mr. NAKAI Kazunori has been working as a civil engineer in the field of water supply, sewage and road construction for more than 10 years. He joined the city of Yokohama in 2013 after the several years experience in private construction company. He was engaged in replacement of age distribution pipe as a manager of design section for a couple of years. From April 2018 to March 2021, he was transferred to JICA headquarters and engaged in some ODA project in some water. He's also satisfied with professional engineer Japan in the field of civil engineering and water supply. Okay, let's welcome our guest speaker for today, Mr. NAKAI Kazunori. The floor is yours.
Thank you, Yoshi-san. Good morning and good evening, everyone. I'm Nakai from Yokohama Waterworks Bureau. Today's topic is Just give me a second to share my slides. Okay, today's topic is continuous efforts for stable water supply in Yokohama. I'm going to share our experience and the system we developed for stable water supply. Japan's first modern water supply system was developed in Yokohama in 1887. Since then, we've been through so many challenges, and we've struggled to build up the current water supply system. Now, we supply safe water from tap 24 hours, 7 days at an affordable price. Today, I'm going to share how we achieve that with you. First of all, let me tell you the key message of my presentation. I believe that the achievement of a stable water supply in Yokohama is the result of secure daily management and operation. Maybe some people think we have a lot of advanced technology, and that's why we achieve stable water supply. Yes, we have some advanced technology, but most part of the water supply system is comprised based on basic technology. Water is the basic human needs, so water supply system shouldn't be too complicated, and it shouldn't be full of advanced technology. It must be as simple as possible to easily access for anyone, anywhere. That's my perspective for water supply system. But in reality, the situation of stable water supply is quite different, even though core technology is quite same. So what makes this difference? What makes this difference is daily management and operation level. Every water utility should get on this good cycle for sustainable water supply business. If you are not on this cycle, you should start with good cycle first, not revenue, because customers don't want to pay water charge without a good service. To keep a good cycle, daily management and operation is critical. From my experience in JICA, most of the water utilities have problems in distribution management and customer management. I think these two are key factors for sustainable water management. For example, water quality is generally good at the outlet of water treatment plant, but on the way to each house, water is getting contaminated before reaching a house. So distribution management is quite important. And even you provide good service, you cannot collect water charge without well-organized customer management. So I'm going to focus on distribution management and customer management in my presentation today. So this is the contents of my presentation today. Let me introduce the outline of water supply system in Yokohama, and then I'm going to share our system of water distribution management and customer management. Lastly, let me introduce track record of international cooperation of Yokohama Waterworks Bureau. Let's move to the outline of water supply system in Yokohama. Yokohama is in the center of Japan, next to Tokyo. This is the elevation map of Yokohama. Red color area is high ground, and blue is low ground. We have both coastline and mountain. As you can see, our topography is complicated. This table shows a basic information of Yokohama Waterworks Bureau. Served population is 3.7 million. Water supply coverage is 100%. Average daily water supply amount is about 1.1 million cubic meter. NRW ratio is 7.4%. Leakage ratio is 5%. And bill collection ratio is 19.95%. Let me compare Yokohama with other water utilities. Country A and Country B also have similar water supply system, but outputs are quite different because of daily management and operation level. This slide shows water balance analysis of Yokohama Waterworks Bureau. Non-revenue water is a major challenge for many water utilities. The non-revenue water ratio in Yokohama is 7.4%. Then it has been 7 to 8% for the last 20 years. Now we have achieved the low non-revenue water ratio. As a breakdown, there are almost no illegal connection in Yokohama. This is due to the fact that the water supply coverage has reached 100%, and we have proper customer management. The meter inaccuracies is less than 2%. The leakage rate is 5%. And customer management is connected to unauthorized consumption and customer meter inaccuracies. Distribution management is connected to leakage. So customer management and distribution management are also important from the aspect of non-revenue water management. This graph shows facility capacity and maximum daily water supply. We developed facilities to meet water demand. Water demand has increased until 1992. We carried out 8 times of expansion project. During the expansion period, we faced a lot of challenges and overcome them, such as lack of funds, unplanned distribution network, and high leakage rate. Now, we are in maintenance phase rather than expansion phase. The peak of water supply amount was 1.61 million cubic meter per day in 1992. Population has been slightly increasing, but the water demand is decreasing recently. The reason of water demand decrease is mainly because of spreading water-saving appliance and equipment. For example, necessary water volume of a washing machine drastically dropped from 220 liters per time in 1990 to just 80 liters per time in 2020. Our revenue has been decreasing along with water demand decrease. On the other hand, facilities we developed during expansion period are getting old, and we need to renew them. That's a challenge we are facing now. This slide shows the water supply system from intake facilities to water treatment plants. We have 3 water treatment plants with 3 water sources. All water sources are outside of the city to secure sufficient water volume and better raw water quality. From the viewpoint of elevation, we have developed gravity flow systems as much as possible to save energy consumption. The pumping system was developed during the period of rapid water demand increase. Intake point was selected at the downstream of the river to secure sufficient water volume for rapid demand increase at the time. This is energy consumption map. Area of low energy consumption is covered with gravity flow system. area of high energy consumption is covered with pumping system. In order to reduce energy consumption, we are prioritizing 2 gravity flow systems. Actually, we have a plan that we transfer intake point to upstream and abolish the popular line of water treatment plants. Okay, this is the end of outline of water supply system of Yokohama Waterworks Bureau. Let's move to distribution management. First, let's confirm water distribution facility. Water supply system consists of intake facility, raw water transmission facility, purification plant, treated water transmission facility, distribution reservoir, pumping station, distribution pipe network, and service pipe. Target of distribution management is from distribution reservoir to distribution pipe network. There are 3 important factors we must control in water distribution management: sufficient water volume for water demand, safe drinking water, and proper water pressure. These 3 are directly connected to service level. As I mentioned, topography of Yokohama is complicated, so it is difficult to properly manage water distribution. Actually, during a rapid increase of water demand, we could not properly plan the distribution networks and pumping facilities. It was hard to know which water reservoir provides how much water to where at the time. In order to solve the issues and provide sufficient safe drinking water 24 hours, 7 days, we developed a distribution block system. So we adapted distribution block system in 1971 to control water volume, quality, and pressure. This is the elevation map of Yokohama, as I already introduced. We divided Yokohama into 25 blocks. And each block has the independent water supply area. One block has 1 reservoir and 1 pumping area and 1 gravity flow area. But few blocks have just 1 pumping area. As you can see, the shape of the block is complicated. This is because vertical boundary of a block is determined by the elevation, and horizontal boundary is determined by the scale of reservoir, allocation of water supply, and physical obstacles such as river, rail, and so on. Actually, the boundaries of blocks are not fixed. We sometimes change the boundary to optimize distribution management. The merits of distribution block system are accurate understanding of water distribution situation, proper water pressure management, minimization of accident impact, easy identification of accident impact, and backup by water interchange. So in following slides, let me explain more detail of distribution management with distribution block system. Okay, water demand fluctuates through a year. Usually, summer is the maximum point of water demand. Winter is the minimum point of water demand. In the case of Yokohama, in 2014, maximum water supply was 1.22 million cubic meter per day in summer. and the minimum was 1.01 million cubic meter per day in winter. And also, water demand varies with time. At night, as many people sleep, water demand is very low. After people wake up, water demand goes up. It goes down once in the daytime and goes up again in the evening. This pattern is common in a residential area. If the area is commercial or industrial area, this pattern is quite different. By grasping water demand tendency, we can efficiently control water volume. Distribution block system can easily adjust the fluctuation of water demand. In Yokohama, the capacity of each reservoir is equivalent to 15 hours of the amount of average water supply. We must keep water quality good until water reaches each house. So we have water quality monitoring system. Frequency of inspection is every day for basic items, monthly for more detail, and 4 times a year for 15 items. We can monitor turbidity, color, and residual chlorine at 43 points with automatic measuring instrument. And managing residual chlorine is important to provide safe water. Chlorine is consumed most in the summer due to high temperature. So residual chlorine concentration surveys conducted in summer. Every year, we manage residual chlorine at a range between 0.3 milligram and 0.0 milligram per liter in almost the entire area of Yokohama. We adjust the amount of injected chlorine in consideration with the result of monitoring. As I told you, Yokohama has complicated topography of a combination of uphill and downhill. So if we set low ground as a target, water pressure would not be enough on high ground. If we set high ground as a target, water pressure would be excessive on low ground. This is why we have adopted distribution block system. We divided Yokohama into blocks in consideration with elevation, so we can control water pressure properly. Water pressure control is so important for customer satisfaction. So we have standard design criteria for Waterworks facilities in Japan. The minimum water pressure should be 0.15 megapascal and the maximum pressure should be 0.74 megapascal. Water pressure of 0.15 megapascal can secure the direct water supply for 2-storied building. Yokohama Waterworks Bureau set minimum pressure 0.2 megapascal for 3-storied building. If water pressure is too low, dirty water can come into pipe from outside. If water pressure is too high, the amount of leakage increases. From the aspect of energy efficiency, we expand gravity flow area with a change of the boundary of distribution block. For example, if left distribution reservoir has sufficient capacity to expand gravity flow area with a change of boundary valve from here to here, we can expand gravity flow area. So we always try to expand gravity flow supply area. It is important to grasp the condition of water in distribution network for proper management. Therefore, we are monitoring the status of water condition in real time. This is a screen of real-time monitoring. This monitor has 5 reservoirs and distribution pipelines. We monitor quantity, pressure, quality, such as turbidity, residual chlorine, color with the monitoring system. When something goes wrong in distribution network, the system rings alert. So when the alert rings, we can notice something wrong happening in distribution network and take action as speedy as possible. Replacement of aged pipe is also important for distribution management because leakage from aged pipe results in increase of NOW ratio, water pressure reduction, and water quality deterioration. We have total 9,300 kilometer pipeline in Yokohama, and the Yokohama Waterworks Bureau started the pipe replacement in 1969. We replace about 110 kilometers of pipes each year now, and more than 4,600 kilometers were replaced so far. Accordingly, more than 30,000 leakages were found in early days, but currently, the number of leakages decreased to less than 2,000. And the leakage rate also dropped from 20% in 1970 to 5% in 2019. And next is customer management. Please look at the pie graph. This shows the Yokohama Waterworks Bureau's account of 2019. Revenue from water charge is accounted for 80% of entire revenue. With water charge revenue, we can invest in facilities and maintain good water supply service. Good water supply service results in high customer satisfaction, and satisfied customer pay water charge. This is the cycle of the sustainable management of water supply service. To keep good water supply service, we need to collect water charge. To collect water charge, we need well-organized customer management. It is very important to identify customers in order to collect water tariff. So we have customers ID system, and this is an essential tool for customer identification. Each connection has ID based on their location. The ID is linked to connection place, not person. This is customer ID plate. After the completion of the construction, our staff install the connection, and put this plate. This plate is put on beside the door. After that, we register a new customer ID to our database. Customer ID is composed of 9 numbers, and one connection has just one customer ID. First 2 digits are word code, middle 2 digits are town code, last 5 digits are connection code. Here is the actual screen of customer database we use. We have customer's ID, customer's name, address, payment option, and so on. Every staff of water charge section can access to this database. The staff input the information into database, and we can share customers' information on real time. This screen shows records of meter reading. We can check customers' water consumption, and this helps us to identify unusual water consumption compared to previous water consumption. This screen shows information about payment. We can check water charge, due date to pay, and payment status. With this database, we keep recording and updating customers' payment status properly. Updating new connection information properly is also important. Application flow for new connection is clearly defined in Water Supply Ordinance of Yokohama. This is an application flow. In Water Supply Ordinance of Yokohama City, new house connection shall apply to Yokohama Waterworks Bureau. Then there are many things that we check in design documents, such as material, construction method, water pressure, water consumption, pipe size, meter location, and others. And the contractor needs license approved by Yokohama Waterworks Bureau to install new connection in order to secure the quality of connection. After all items are past the requirements, construction starts. When construction is completed, the customer submits a completion notification with as-built drawings. After that, we carry out a completion inspection. After completion inspection passes all requirements, a meter is installed to start supplying water. And then finally, we register the new connection in the database. This is an example of as-built drawing. It includes location map, piping diagram, and material list. So we identify location from location map. We understand the structure of house connection from piping diagram, and we check material of house connection from material list. Plan view of in-house piping also submitted, and we can inspect submitted drawing. We know the structure and layout of in-house piping from plan view. Water meter accuracy is essential in order to grasp accurate water consumption. There are 1.83 million water meters in Yokohama. In Japan, meter must be passed in the process of approval and verification, regulated by Measurement Act, so we can procure reliable water meter. Verified meter has verification mark on it. And meter should be replaced within 8 years in accordance with Measurement Act. This slide shows standard procedure of meter reading. At first, meter reader checks the meter. If meter reader finds irregular water consumption, which means more than 30% increase or decrease compared to last meter reading, we read the meter again, then try to find the reason of that. We contact the customer and ask them if their usage situation changed or not. If not, it could be leakage, faulty meter, or unauthorized water use. After we find out reasons and confirm actual consumption, we proceed to billing procedure. And if there is a possibility of leakage, we inform customers the possibility of leakage and necessity of repair work. Making standard procedure and always following the procedure help us to secure meter reading and billing. Let me show you the key message again. As I explained, secure daily management and operation is critical for stable water supply. And as everyone knows, water is essential for people's life. So we keep improving our service for people in Yokohama. We have overcome so many challenges to stably supply water for people in Yokohama. Now, we are facing new challenges and doing our best to keep sustainable water supply for people in Yokohama. I hope every water utilities in this webinar achieve the stable water supply for your people. Finally, I'd like to introduce the International Corporation of Yokohama Waterworks Bureau. International cooperation is one of the unique characteristics of Yokohama Waterworks Bureau. Since 1973, Yokohama Waterworks Bureau has dispatched staff to overseas countries. Now we have dispatched more than 450 staff and accepted more than 4,000 trainees from foreign countries. Recently, we had projects in Vietnam, Laos, Indonesia, Pakistan, and Malawi. We dispatched 20 staff to Blantyre Water Board in Malawi, utilizing the JICA scheme. We've developed a good relationship with Blantyre Water Board in collaboration with JICA. We also have technical cooperation project for Lilongwe Water Board in Malawi. This also JICA's project. Yokohama Waterworks Bureau dispatched the chief advisor for the project. We have achieved stable water supply. So now we have assisted other water utilities to achieve sustainable water supply business. Thank you for your listening.
Thank you for your wonderful presentation, Mr. Nakai. I was so amazed with the total length of the replaced pipes. You said more than 4,500 kilometers in total. It was interesting to see the obvious decrease in the leakage rate in proportion to the replacement of the pipes. By the way, how many years are these pipes durable? It's my one question. Could you answer that question?
Thank you for the question. Actually, we have several types of pipe, but mainly we use ductile iron pipe and steel pipes. So regarding the ductile iron pipe and the steel pipes, we assume the useful life is 80 years for ductile iron pipe and 60 years for steel pipes.
Oh, what a long time. I missed. Oh, and then another question. I think maintaining good services, including pipe replacement, is very difficult. But you mentioned if you give good services, the customers are willing to contact with water board. And as a result, the revenue will be increasing. However, to improve the service levels, financial sources are very necessary. It's necessary. In particular, most developing countries are suffering from the lack of the budget. So in that case, how can we handle with that contradiction? Could you answer the questions?
Thank you for the question. Yes, lack of financial source is one of the big problems for any water utilities to improve service level. Japan, many water utilities also had the same problems, especially during expansion phase. We also struggle to secure funds, budgets. To my understanding, there are 5 main financial sources for water utilities: water tariff, bond issue, loan, subsidy, and grant. In Japan, our accounting system is self-supporting accounting system. It means the cost of waterworks operation should be fully covered with revenue. This is few subsidy from the government. In some countries, water tariff goes to the central government first, and then the government distributes budget to water utilities. So there are various accounting systems in countries. But in the case of Yokohama, we have 2 main financial sources. One is water tariff, and the other is bond issue. Japanese government set up framework that enables us to issue long-term local bond. So we utilize long-term local bond for facility investment. And we have another reason to utilize long-term local bond other than financial aspect. As I explained, useful life of facilities is so long. So future generation also use water facilities we develop now. So from the viewpoint of fairness of cost burden, we utilize long-term local bond for facility investment. Otherwise, the generation at the present pay for the investment for the full cost we should cover. It's not fair. So we utilize long-term local bond. And in the case of developing countries, I think fund from International Development Bank or donors such as JICA, ADB, World Bank is one possible option and effective to improve financial condition. But water utility should not rely on too much donors fund. Water utility should make own efforts to improve production efficiency, energy efficiency, work efficiency, and human resource development. So in conclusion, grant, subsidy, and long-term low-interest loan are helpful as financial sources for developing countries. And in the meantime, water utilities make own effort for sustainable water supply business. That's my answer.
Thank you. I understand. So issuing long-term bond is one of the key to the sound water supply system, as well as collecting water bill. Thank you so much. Now, I would like to move on to the Q&A session. And I think we have some questions posted from our audience. So I'd like to get Sai-san to introduce these questions. Over to you, Sai-san.
Thank you. Thank you, Reiko-san. We have received a lot of questions, especially the leakage issues. So I would like to pick the leakage issue as the first question. One question is, how do you control leakages? And another question is that there are many leakages in 1970s in Japan, but the facility is not dilapidated. Why are there so many leakages at the time? What measures were most effective to address these leakage issues? Mr. Nakai, could you answer these questions?
Thank you for the question. So first question is how do we control leakages?
Yes.
Okay. Yes, it's very important to control leakage. Actually, I expected this question, so I prepared some slides. So let me explain with slides. So as I introduced, this is our water balance analysis of Yokohama Waterworks Bureau, and leakage percentage is 5.0%. And now our non-revenue water ratio is nearly equal to leakage ratio. So it is very important for us to keep this low leakage ratio. And actually this left picture is one of the big leakage accidents in Yokohama. The water went up to 6 meters high, but actually the most of leakage happened in service pipe. And there are several measures and equipment for leakage. And this slide shows leakage detection. And there are many leakage detection equipment, but depends on situation. We should choose the appropriate detection equipment. So actually, now we outsource leakage survey. We divide entire Yokohama city into blocks, and just one. We outsource most of entire city of leakage survey, but we conduct the leakage survey ourselves. But leakage survey. Okay, so this is the history of our leakage measures. So we change the leakage method step by step as our situation improving. Now we use leak noise collection. Sorry, our main measures of leakage is aged pipe replacement. This is now our main countermeasures. But of course, in the meantime, we also conduct the underground leakage survey. So we have the team dedicated for leakage detection, and the division of leakage detection was established in 1948. Since then, we keep we continue to try to reduce and keep low leakage ratio. Yes, that's my answer for this question. And sorry, what is your second question? You see.
Yes, my second question is in 1970s, there are not so many old aged pipes, but there are many leakage issues. Why they happened and how to address these issues in Yokohama?
So in 1992, let me check the leakage rate. In 1992, yes, our leakage ratio is very high, and the reason of that is mainly because of there are a lot of leakage at the time. So main reason was the leakage at the time, and we start to find out the leakage and try to reduce the leakage volume. And of course, we have other reasons. And as I explained, there are many reasons of the factors of leakage. And now we use a ductile iron pipe, which is very strong and reliable. But in the past time, the material was not strong compared to the recent material. I think that's one reason. And the other reason is maybe the construction supervision. Now we have manual and organized construction supervision procedure, and we check every step of the construction phase, so we can check the quality of construction step by step, one by one. So if the construction supervision is not good, and the quality of construction is not good, the leakage happens soon after the new pipe is installed. So I think that's the reason now we can keep low leakage ratio. Yes, that's the answer from me.
Okay, thank you, Mr. Nakai. Thank you for your very detailed answers. So I'd like to move on to the next question about water distribution block. The question is, the water pressure management. The question is that I have a question about water pressure management. Increasing minimum water pressure and changing pumping area to gravity area sounds contradicting somewhat. Is it possible to implement simultaneously at the same area?
Thank you for the question. Yes, that's actually the the issue we are facing. Now we are trying to expand gravity flow area. So we sometimes change the boundary valve, then expand gravity flow system. In the meantime, yes, we also have pumping area, and our target is 0.2 megapascal of water pressure control. So, but as I told, we conduct the detailed survey of water pressure in entire Yokohama, so we can grasp the water pressure in the detail of Yokohama. So we can reduce the pumping head as much as possible, I mean, as low as possible until the lowest point of the water pressure is until 0.2 megapascal. So we should keep 0.2 megapascal of minimum pressure, but in the meantime, we try to reduce pump head based on our detailed survey, because we have some space to reduce pump head, because now our water pressure have enough space to reduce, because not 0.2 megapascal our water pressure is now. So we can reduce water pressure with reducing pumping head. But we must keep 0.2 megapascal after we reduce pumping head or after we change the boundary valve. Yes, that's my answer.
Thank you, Mr. Nakai. Okay, I would like the next question. Move on to next question. I'd like to pick up the customer management, especially meter reading. The question is, in customer management, what technology do you use for meter reading and customer payment? For transfer of meter reading and payment data to your customer database real time. Why is Yokohama not using prepaid and automated water meters? Could you answer this question, Mr. Nakai?
Yeah, thank you for the questions. And the meter reading is not my field, but I try to answer the questions. So actually, regarding meter reading, the meter reader goes to the site and then reads the meter. And they have gadget. The gadget has some data of the customers, and they input the consumption data at the site, and the gadget transmits data to our database. And so why we don't use the prepaid meter? So yes, prepaid meter is very useful, but many people think if we install prepaid meter, we don't need to go to the site to read water meter. But in my understanding, even we install prepaid meter, I think we should go to the site to read meter, because if we don't go to the site, customer can, bypass the service pipe, or they can break water meter, and so we can not find illegal connection. But if we go to the site, we can detect the unusual consumption condition, and we can detect illegal connection. I think this problem happens in some countries installing prepaid meter. So we don't install prepaid meter now.
Okay, thank you very much. Thank you for your detailed answers and clarification. I'm afraid that it's about time. I'd like to thank again Mr. Nakai for your kind answers, and also we would like to thank all the participants and participants for posting questions. I apologize due to the time constraints. We can't answer all of your questions. So let's go back to the moderator.
Okay, thank you so much answering the questions. Mute. Sorry. Thank you so much for answering the questions. Before we finish, we would like to announce the next JWF webinar. The fifth JWF webinar will be held on November 24th. Topic is a regional inclusive public-private collaboration for water conservation. Speaker will be Mr. Tsutomu Nagata. He's a senior counselor of the Environment Bureau and director of the Water Conservation Section, Kumamoto City. All right, that's wrap up for today's webinar. Thank you again for your wonderful presentation, Mr. Nakai. The recording will be viewed on my website later. Finally, I'd like to, it would be grateful if you could take the time to answer the questionnaire. And also thank you so much for your active participation. Thank you to all participants. We look forward to welcoming you to our next webinar. Thank you so much. See you next time. Bye-bye.